Assalamu alaikum. Starting with the name of Allah who is most beneficent and merciful. My name is Wajid Ali and my registration number is 17 NTU0145.
The topic of my presentation is DMA, means Dynamic Mechanical Analysis.
The contents of my presentation are: what is DMA? DMA differ from thermomechanical analysis, the block diagram of DMA, how does a DMA work, what does a DMA measure, how does the storage modulus in a DMA runs compared to young modulus, what is damping, modulus as a function of temperature, how do I get good data, detecting a TG value sometimes not agree with DSLC value, use the DMA to study curing, frequency scan and multiple frequency, time temperature superposition, sampling amines in a fluid, ultraviolet curing. Now first of all, what is DMA? Dynamic mechanical analysis is called DMA. DMA is a technique where a small deformation is applied to a simple cyclic manner. This allows the material response to a stress, temperature, frequency and other values to be studied. This term is used to refer the analysis that perform the test. DMA is also called DMTA, that called dynamic mechanical thermal analysis. How does DMA differ from thermomechanical analysis? Thermomechanical analysis or DMA apply a constant static to a material and watches the material change as temperature or time varies. It reports dimensional changes. On the other hand, DMA apply an oscillatory force as a set frequency to a sample and reports change in stiffness and damping. DMA data is used to obtain modulus information while DMA gives an coefficient of thermal expansion. Both detective transmission, but DMA is much more sensitive. The block diagram of DMA. The sample is clamped in a measured head of DMA instrument as shown in figure. During measurement, sinusoidal force is applied to a sample via the probe. DMA is used to measure the various types of polymer material using different deformation mode. There are tension, compression, dual bending, three-point bending, shear mode, and most suitable type should be selected depending on the sample shape, modulus and measurement purpose. How does DMA work? DMA work by applying sinusoidal deformation to a sample of known geometry. The sample can be subjected by controlled stress or a controlled strain. For a known stress, the sample will then form a certain amount. In DMA, this is done sinusoidally. How much is deformed is related to stiffness. A force motor is used to generate the sinusoidal wave and is transmitted to sample via a drive shaft. One concern have always been compliance of his drive shaft and the effect of my stabilization bearing to hold it is in position. A schematic analytic train of DMA 8000 figure 1 shows the innovative design. How does DMA measured? As shown in figure that DMA measured stiffness and damping. These are reported as modulus and tan delta. Because we are applying a sinusoidal wave, we can express the modulus as in phase component, the storage modulus, or an out of phase component, the loose modulus sees figure 2. The storage modulus either E or G measure the sample elastic behavior. The ratio of loss the storage to the tan delta and often is called damping. It is measure the energy dissociation of a material. How does storage modulus in DMA run compared to young modulus? While young modulus, which is calculated from slope of initial part of stress strain curve, is similarly conceptual to the storage modulus, they are not the same, just as shear, bulk and comparison modulus of material will differ. Young modulus will not have the same value as the storage modulus. Now let's discuss about what is damping. Damping is the dissipation of energy in a material under cyclic load. It is measure of how well a material can get rid of energy and is reported as a tangent of the phase angle. It tells us how good a material will be absorbing energy. It varies with the state of material, its temperature and with the frequency. Modulus as a function of temperature. Modulus value change with temperature and transition in a material can seen as change in E and tan delta curves. The include not only the glass transition and the melt, but also other transitions that occur in glassy and rubbery plates. Shown in figure, these transition indicators subtotal change in material. The DMA 8000 unique low storing temperature of minus 190 degrees centigrade is standard furnace and minus 196 degrees centigrade is the flowed bath. Let your easy took the in small modulus motion as shown in figure 3. How do I get good data from DMA? Good data requires several things: a properly calibrating instrument, a properly prepared specimen with reasonable aspect ratio, using the right geometry and applying both reasonable strain and heating rates. A properly calibrating instrument requires calibration of both temperature and force. A well prepared specimen should be in even thickness with parallel sides and right angle. Assuming the correct choice of geometry for sample, a deformation of 50 microns and heating rate of 2 to 3 degrees centigrade per minute as normally for fine. How can I detect a TG value? The glass transition temperature and the TG value is shown in large drop in a storage modulus when viewed on a large scale against in a linear temperature scale as shown in figure. Current peak in the 10 delta as seen. The value reported as TG value with the industry with onset of E drops. The peak of 10 delta and the peak of E curve being the most commonly used as shown in figure. Running in melt frequency scale and calculating the activation energy of transition allows you to decide if the transition is really a TG. The activation energy of TG is of 300 to 400 kJ per mole. In comparison, a TB has the activation energy about 30 to 50 kJ per mole. TG value sometimes not agree with DSC value. That's actually not surprising. The glass transition is really a range of behavior where scientists have agreed to accept a single temperature as an indicator per certain standards. Different industries have used different points from same data say that vary a match value of 15 degrees centigrade. DSC, TMA and DMA means different processing and therefore the numbers vary a bit. You can see as much as 50 degree different in delta value from DSC to DM delta reporting a peak of 10 delta as figured in 5 example. How can I use DMA to study curing? DMA is commonly used to study curing of material as this process involved in dynamic increase in modulus value. It's commonly used to get both the point of degradation and point of verification of thermosetting material. Cures can studies with temperature ramps and fixed temperature. The DMA 800 can be configured with optical quartz window and specially fixed allows to study photoring system. Now let's discuss about frequency scan system. Most material can see many frequencies in their final product. An example in a rubber used in windshield wiper with a range of operating frequency and temperature in use. Modulus frequency plot can tell us how much material will change frequency changes. For viscous material, this can give useful information about its flow. It's often available. It's not just look at modulus frequency at one temperature, but can scan many frequency as you can material heat. This allows you to see how transitions shift under the influence of frequency. For example, in some polymers, a shift from 1 to 100 Hz will move Tg by 14 degree, which could cause a material to fail if high frequency is not considered its design. Time temperature superimposition. The William Lauder Felder model as DLF claims that under certain conditions, times and temperature can be mathematically interchanged. As shown in figure that ATT show the figure tells us how data collecting a frequency scan adds a range of temperature to its predict behavior at frequency that not directly measurable. The DMA 800 had advanced software that makes a fairly simple process. The data is often converted to time to predict lifetime performance. One should note that TT calculation result on same assumption and is often involved if the assumption areas met. on the basic assumption in a single relaxation time and is tested by using vertical cold point as shown in figure. Now let's discuss about the samples immersed in a flood. Certain solvent can cause a material to soften while they are exposed to them. Others can react with them and harden the material. Both of these effects can cause failure in biomedical device, coating paint, to name only a few. In addition, the effect of stress and solvent often different than just coating material in a solvent and then testing it in air. The DMA 800 flood bath allow coating data of same immersed in solution under variation of coating as shown in figure. Ultraviolet curing. A photocalorimeter only look at energy of photocuring. Photocuring in DMA lets you can see how physical properties change and when their modulus of curing material has reached the acceptable limit in a term of strength and stiffness. The information is important for cost-effective design of your own cured circle. Using DMA with ultraviolet also allow you to emulgate and degradation of material and so evaluate addition package formation etc.